Okay, let's see how to graph quadratic functions given the vertex form of the equation. So this is the vertex form, which is y equals a times x minus h squared plus k. The a represents the dilation of the graph. H is the x value of the vertex, but it's actually x minus h equals 0. So if this would say x minus 2, then negative 2 is not the x value. It's actually 2. You have to set the inside equal to 0 to find the axis of symmetry, which is nothing but the x value of the vertex. And then k is just the straight up k value, which is the y value of the vertex. So if it said plus 3, then it's x comma 3, which is the y value of the vertex. Question 1, we have graph the function y equals x minus 3 squared minus 3. So our a values is 1 here because it's not shown, but we have our vertex. So we can just label this as v, and the coordinates of our vertex is 3 comma negative 3. Remember, x minus 3 equals 0, and you solve for x, which is going to equal 3. So now we have to find 2 points to the right and left of the vertex. So the 1 point after 3 is going to be 4, so let's take f of 4. And now if we solve for, or if we put 4 into this equation, we're going to get 4 minus 3 is 1, squared is 1 minus 3, which is going to be negative 2. Now if we take f of 5, which is the next point after 4, we're going to have 5 minus 3 is 2, squared is 4, and 4 minus 3 is 1. Now, we found 2 points to the right of the vertex, and we also need to find it to the left, but since a quadratic function is symmetrical, the y values are going to be the exact same. So now let's just make a table, and I'll show you what that means. So if we have x and y here, if we take the first point to the left of 3, which is 2, and then another point to the left of that is 1, so we have 1, 2, 3, 4, and 5. Now we have these 5 points, and now we just take our y values. So we know that for 3, it's going to be negative 3, and we calculated for 4, it's negative 2, and we calculated for 5, it's 1. And now these are going to be the exact same as these. So the point that corresponds with 5 is 1, which is going to be 1, and the point that corresponds with 4 is 2. So this is going to be negative 2. Okay, now we have our 5 points that we can plot on the graph. So let's start with our vertex, which is 3 comma negative 3. So that's going to be right around over here. 3 comma negative 3. Let's label that. And then let's label our points to the right, which is 4 and negative 2. So it's going to be right here, 4 and negative 2. And then we have 5 comma 1. And on the left side, it's going to be exactly symmetrical. So it's going to be 2 comma negative 2. And then we have 1 comma 1. Draw a general curve of what it would look like. So it will look something like that. A little more curved, but these are the points that it would follow. Question 2, we have graph the function f of x equals x plus 2 squared plus 1. So our a value here is only going to be 1, so there's no dilation, but our vertex is going to be at negative 2 comma 1. Okay, so let's find 2 points to the right and left. So let's just start with the right. So 1 point to the right is negative 1. And if you plug negative 1 in here, you're going to get negative 1 plus 2 is 1, and 1 squared is again 1, and 1 plus 1 is 2. So now, if you do f of 0, this is going to equal 2 squared, which is 4, plus 1 is 5. So now we have our points for the right side, which means we also have our points for the left side. So let's draw our table. So 2 points to the left of negative 2 is going to be negative 4, and then negative 3, negative 2, negative 1, and 0. So now we have these points, and now let's plug in our y values. So negative 2 is going to be 1, negative 1 is going to be 2, 0 is 5. So here again, 0 corresponds with negative 4, so this is 5, and -1 corresponds with -3, so this is 2. So we have our 5 points here, so let's graph it over here. So our vertex is -2, 1, so our vertex is over here. And the graph is going to be sloping upwards, right? Because A is just 1, and that's a positive number. So now let's graph our points to the right. So -1, 2 over here, and 0, 5, which is over here. And then we have -3, 2, which is going to be symmetrical, which is over there. And then we have -4, 5. So that's going to be around right there. And now we can just draw an estimate of the curve. And that's around what it would look like. So now let's graph or label the points. -2, 1, -1, 2. This is 0, 5. And then on our left, we have -3, 2, and -4, 5. And these are our 5 points. Question 3, we have graph the function f of x equals -2 times x plus 2 squared plus 4. So now we have a dilation and it's negative. So the concavity of the graph, which tells us if it opens upwards or downwards, is based on the a value. And here our a value is -2. Since it's negative, the graph is going to be opening downwards. The previous 2 equations we've had where a was just 1, which is a positive number. So that's why the graph opened up. But since it's -2, it's going to be opening downwards. And the vertex is going to be a maximum. It's going to be the highest point. And to graph this, we're going to do the exact same thing, okay? So first, let's find our vertex, which is going to be the same, which is -2, 4. And now let's find 2 points to the right. So 1 point to the right of -2 is -1, so f of -1. And now if we put this in, we'll have -1 plus 2, which is 1 squared, is 1. 1 times -2 is -2, plus 4 is 2. Now let's put in f of 0. So this is going to be 2 squared, which is 4. 4 times -2 is -8, plus 4 is -4. And now let's make our table. We have x and y. So 2 points to the left of -2 is -4, and then -3, -2, -1, and 0. And now let's plug in our points, or our y values. So -2 will be 4, and we calculated -1 will be 2, and this is -4. 0 corresponds with -4, which is also going to be -4. And -1 corresponds with -3, so this is 2. Now we have our points again. And another thing to mention about the a value is if you take the absolute value of it, the greater it is from 0, the more condensed it's going to be. And the closer it is to 0, the more stretched out it's going to be. So if we had a to be like 10 or 20 or something, it would be very small. The graph would be something like very, very shrunken. The shape's not entirely correct, but the curvature is going to be very small. But let's say we had a to be 0.01 or something, it would be very stretched out. You see the difference? This is when the a value is far from 0, the absolute value. And this is when the a value is very close to 0, the absolute value of it. Okay, so now let's actually graph. So we have -2, 4. So -2, 1, 2, 3, 4. And then we have -1, 2. We have 0, -4, 1, 2, 3, 4. And then we have -3, 1, 2, 3, 2. And then we have -4, -4 as well. So -4, 1, 2, 3, 4, and down here. Okay, now let's just draw the general shape of it. Okay, so this is the general shape of it. It would be a little more extended out, but it's okay. This is just the general shape of it. So now let's label the points. So our vertex is -2, 4. And then we have -3, 2, -4, -4. And this will be over here, -1, 2. And here is 0, -4. And this is our final graph of the function.